Okay, so we're going to go ahead and get started. This is the uh, Test 3 review for stats for Fall B, covers chapters 4 and 5. My name is Maxine. I work at the Academic Support Center. If you want a recording of this, then you can send me your email address. You can either send it to maxine.horn@Daytona State, or the email here works as well. My first name is Brandy. I know it's confusing. I go by Maxine. That's my middle name. Okay, so this review is being held on a Monday. Normally our reviews on Tuesdays. Our reviews are on Tuesdays, but the college is closed tomorrow in observance of Veterans Day. So that's why we're doing it on Monday instead. Your test opens on Wednesday, so we wanted to do it before your test opens, not after your test has opened. All right, so for these chapters, I did go ahead and create a sort of, I wouldn't really call it a study guide, but sort of like an example of maybe some notes that you might want to take as you're going through these chapters. So I will be uh, attaching this. It's nothing official or anything. It's just some handwritten notes that, like I said, are kind of an example of what you might write as you're going through and, reading the book or the electronic book, however you're getting this information, and what your notes might look like. This is, it's not required. And what works for one person is not necessarily going to work for somebody else. We all have different sort of learning styles and note-taking styles. So this is just one example of something that you might do. But what I've done is I've gone ahead and highlighted every time I had the directions for how to do something in the calculator, because I know that that's something that you're definitely going to need um, to do. Hold on just a moment. It looks like maybe somebody's. Okay. Yes. All right. Yeah. So, like I said, I've highlighted where I have directions on how to do things in the calculator. Um, just kind of, writing out kind of like some definitions that might be important, some examples of how to do things, formulas. Here, I meant to write this after I wrote this, but I forgot to write this. And I wrote that first, and I wasn't going to erase all of this and write it down here because this is just very informal. So that's just why I've got that line there, because this was supposed to be directly after this. That's all that is. So yeah, I've boxed in some formulas. I have, like I said, highlighted where, I have directions on how to do things in the calculator. Um, you know, Little helpful diagrams, just some things that you might find are helpful when you're going through and learning material for the first time. You might want to create something that looks kind of like this. I will be referring to this throughout the review because it's got, hey, this is how you do it in the calculator. And yeah, and then I think this is the last page. Again, some more formulas, aspects of theorems. You get the idea. Again, your review notes could look very different from mine, and that's totally okay. All right, so let's go ahead and get started. So state whether the variable is discrete or continuous, the cost of a statistics book. So if something is finite or countable, finite, countable, that's going to be discrete. Okay, so when we're talking about cost, or we're talking about dollar value, right? So that only goes to 2 decimal places. Well, if it only goes to 2 decimals, that is finite and countable. Okay, an example of something that's continuous would be something that could be, well, actually, let's go ahead and pull up our little definitions here, right? Continuous random variables are, there's an uncountable number of outcomes. There's an infinite number of outcomes. It's represented by an interval on a number line. So if I said, somebody's, I don't know, blood pressure or something could be anywhere between something and something. We're really only limited by the ability of our tools to measure that number, but that number could be any number in between. Like, I mean, this isn't assigned to anything, but if I have the number 2 and I have the number 3 and I said, well, how many numbers are in between 2 and 3? There's an infinite number of numbers in between there, right? So I could have 2.5, but I could also have 2.0000005, and then I could put 1,000 zeros and then a 5, right? So that would be continuous. Continuous is it could be anything in between here, whereas discrete, it is finite, it is countable. So when we're talking about money, the cost of something, that's going to be discrete, finite and countable. Okay. And then, oh yeah, okay, that's where the blood pressure thing comes in. State whether the variable is discrete or continuous. The blood pressures of a group of students the day before their final exam. Hopefully your blood pressure does not go up too much as you're studying for your exam. But yeah, it can take on any value within, let me actually write that out. It can take on any value within a given range. And we're limited only by the precision, that was the word I was looking for, limited only by the precision of the measuring instrument. So continuous is what this one would be. All right, so the random variable x represents the number of credit cards that adults have, along with the corresponding probabilities. Find the mean and standard deviation. So for this, where's my calculator? So we're going to be doing this in the calculator, and we're going to be doing this in a very similar way that we did when in previous chapters, right? We have an L1 and we have an L2, right? So in the calculator, I got to do this so it don't get the reflection. We're going to be going to stat, okay, and then we're going to be going to calc. Hold on, stat, and then that's all caps. Try and make it look exactly like what it looks like. Okay, and we go number 1, edit, right? This should be looking familiar. You've done this before. And we're going to put these things in L1 and these things in L2. So I'm going to arrow back over. Quick review for those of you that maybe forgot or haven't seen the other reviews. If you want to clear an L1 or an L2 or any of these lists, you arrow up so that you're highlighted on the name of the list, the L1. You hit clear and then you hit enter and it'll clear the whole list. Okay, so I'm going to do that for both of these, and I'm going to put in 0, 1, 2, 3, 4, and the corresponding probabilities. I assume the probability that somebody has that many. Okay, so then we're going to go input into L1, which is your X, and L2, which is your probability of X, right? So you want to make sure that they're in that order, the X and then the probability of X. And then you're going to go back to stat. And you're going to arrow over to calc. Oh, sorry, we're not arrowing over to calc. I don't know why I wrote that. Let me get my better eraser here. Getting ahead of myself. We're not calculating until after we've put these things in. This was just, we were already in edit. All right, now we're going to calc. And we're doing number 1, which is var stats. All right, so that should look familiar because that's what we've done previously. Okay, we have to tell it what is our list, and we need to tell it L1. So you might already have L1 and L2 sitting there. If so, that's great. If not, You see the L1 is written here above the number 1, so you have to hit second. You can kind of think of it like a shift button. Right? Second 1 tells you L1, and then the frequency is where we're putting the probability. Okay, so that's where we put L2. So L2 is directly above the number 2, and then we calculate. All right, so that's how we're getting our mean, right? Our X bar. X bar is our mean. Because remember, whether this is, well, this is a sample, but if we had a population, the formula for population mean, right, that's what the symbol is, population mean, is the same as the symbol for, or I'm sorry, the formula for population mean is the same as the formula for sample mean. So that's why your calculator just has the one symbol, but it does have two different symbols for standard deviation. So population standard deviation versus sample standard deviation. Okay. And what you're going to find, just a little thing that you'll notice, is that when you put in a probability rather than a frequency, it won't give you the S. You'll notice that as you do these problems, it's only going to give you that. So don't freak out about that. That's okay. We're just looking at that for these problems because it's giving us the probability rather than a frequency. So just make sure you're looking at your correct symbols. 1.23 is our X bar, that's our mean. Our standard deviation, we can only look at the one it gives us, which if we round to 2 decimals is 0.66. Okay, fairly straightforward. You just have to remember your X's are L1, your corresponding probabilities are L2. Okay. All right, use the probability distribution to complete parts A through E. All right, so the probability distribution of the number of overtime hours worked in 1 week per employee. So find the probability of randomly selecting an employee whose overtime is 1 or 2 hours. Okay, so 1 or 2 hours, that means we're going to do the probability of 1 hour plus the probability of 2 hours. Okay, so the probability of having 1 hour of overtime is 0.058, and the probability of having 2 hours of overtime is 0.127. So we're going to go ahead and add those up together. Also, real quick, I just did second mode, which does quit to get out of that menu. All right, so I'm going to do 0.058 plus 0.127, 0.185, right? That's how we're getting 0.185. That's the probability of 1 or 2 hours. Okay. Find the probability of randomly selecting an employee whose overtime is 2 hours or less. Okay, so 2 hours or less. So we have 0, 1, 2, 3, 4, 5, and 6. 2 hours or less would be these, would be either 0 or 1 or 2. Now there's two different ways that we can do this. We can either kind of use the same process we used in part A, where we say, okay, I'm going to add the probability of 0 plus the probability of 1 plus the probability of 2, and I'm going to get the probability of 0, 1, or 2. Or we could say, hey, I've already done half the work here. I already know what this plus this is. So if I already have this plus this, I really just need to take that number, that 0.185, and add to it the probability of 0 overtime hours, right? So the probability of 0 overtime hours is 0.026. And the probability of 1 hour plus the probability of 2 hours is 0.185, because we already did that math, so why do it again? So I can just hit the plus sign and it'll just add to the previous thing that I had. It'll say, oh, you want to take the answer and add something to it. So this is answer plus, when all I did was hit the plus sign, 0.026. And that's how they're getting the 0.211. Now, if you don't feel comfortable with that and you want to prove it to yourself, you can just go through and you can do it the quote unquote long way. And you can say, okay, 0.026 plus 0.058 plus 0.127, and you can see that you're getting the same thing, okay? But they're doing this because they want you to see that if you've already done, well, they're doing this for a lot of reasons, but one of them is they want you to see that if you've already done part of the work in a previous part of the problem, you can save yourself some time by just doing the part that's left, okay? So 0.211. Okay, part C. Find the probability of randomly selecting an employee whose overtime is from 3 to 6 hours inclusive. So inclusive means we are including our barrier numbers. So our barriers are 3 and 6, and we're going to go ahead and include those. If they had said exclusive, then from 3 to 6, we would have only done 4 and 5. It's kind of a weird way to say it, but they may say it like that. They probably won't, though. But let's go ahead and write that out. 0, 1, 2, 3, 4, 5, 6. From 3 to 6 inclusive. Okay, so again, there's going to be two ways that we can do this, right? So we can either do the probability of 3 plus the probability of 4 plus the probability of 5 plus the probability of 6. We could do that. We could add up those four numbers. And because we already have those numbers, it's not that big of a deal to add them up. It's not going to take us too much time. Or we could see that the complement of that, remember complement is 1 minus the thing, all of these all together add up to 1, right? That's not the whole thing, but that's, one of the defining features of these types of setups is that we have a probability distribution here. If I add up all of the probabilities, they have to add up to 1. Okay, so if all of these together add up to 1, and I already know what this number is, what all of these added together are, then instead of sitting here and going this plus this plus this plus this, I can just say 1 minus the complement of what they're asking for, the probability of 3 or 4 or 5 or 6, right? So 1 minus, so the complement of that is the probability of 0 or 1 or 2, right? The complement of 3 or 4 or 5 or 6 is 0, 1, or 2. I should say the probability of each of those things, okay? So 1 minus the probability of that. So 1 minus the thing that we calculated just a second ago, right? So 1 minus, and then, sorry, the reflection always makes that more difficult. If I want to tell the calculator, I can either type that in, right, 0.211, or I can ask the calculator to use the last answer that was in the calculator. So down here at the bottom, I don't know if you can see where it says ANS above the negative sign. So again, I'm going to hit Shift and then that, and it'll say, oh, 1 minus the last answer that you had, excuse me, and then I get 0.789, which is how they're getting that. Or again, I could say, okay, I'm going to do 0.307 plus 0.212 plus 0.18 plus 0.09, and I'm still getting 0.789. Okay. Either way, you get the same thing, but they're wanting you to understand this relationship between the complements and remembering that all of these added together are 1. Okay, part D, find the probability of randomly selecting an employee whose overtime is from 1 to 3 hours inclusive. So again, that's 0, 1, 2, 3, 4, 5, 6, from 1 to 3 inclusive. 1 to 3. So again, there's several ways you could do this. If you wanted to get fancy, you could say, oh, well, I already have this, or I'm sorry, I already have, the 1 and the 2. Actually, I guess that's not that fancy. That's just one step. I already have 1 and 2. I really just need to add 3 to it. Let's do it that way. That's going to be the fewest number of steps. So the probability of 1 or 2, which we already have, plus the probability of 3. We already have the probability of 1 or 2, it's 0.185, and the probability of 3 is I was looking at the wrong number. Consistency, let me put the 0 in front. So I'm going to do 0.185 plus 0.307, and we get 0.492. And again, if you don't recognize, oh, I was already given part of that, you can absolutely just say the probability of 1 plus the probability of 2 plus the probability of 3, and you'll still get the same answer. And last, find the probability of randomly selecting an employee whose overtime is at most 4 hours. Okay, so at most 4 hours. So you want to make sure that you're familiar with these types of phrases that they're going to be using. Okay, if I have at most 4 hours, that means that I have, oh, I forgot the 6, is that I have everything below 4 and including 4. Okay, so again, lots of different ways to do this. I think probably the fastest way to do this is going to be to find the complement and subtract that from 1 to get this. Okay, so the probability of 0 or 1 or 2 or 3 or 4 is the same as 1 minus the complement of that, which is the probability of 5 or 6. Okay, so the probability of 5 or 6, and if I just kind of expand this, you don't have to write it this way. I'm just kind of, making it extra clear of what exactly we're doing here. The probability of 5 is 0.18. The probability of 6 is 0.09. And you can plug this all into the calculator all at once. I'm going to do it separately, but I'm going to take the probability of 5 plus the probability of 6, and that gives me 0.27. So this is 0.27. So this is going to be 1 minus the last thing I have, or 0.27. And that's how we get the 0.73. Again, you could absolutely sit here and go probability of 0 plus probability of 1 plus probability of 2, so on and so forth, up to 4. But what you're going to find is that eventually you're going to be given some problems where it just doesn't make sense to do that because it'll just take too much time, right? There's only 6 things here. So, it's not the end of the world if we add 5 of them up together or 4 of them up together. I'm sorry, I said 6 things. There's 7 things because we also have 0. But sometimes you're just going to have a lot more than that, and it's just not going to be feasible. So they want you to get familiar with this idea of doing the complement or doing parts and adding the missing part and that sort of thing. Okay. All right. Number 5, use the data given below. Using the data given below, determine whether it would be unusual for a household to have no HD televisions. So, the number of televisions per household in a small town, 0, 1, 2, and 3. They're asking about no HD televisions. None is 0. The probability of having 0 HD televisions is 0.03. So we've talked about in previous chapters that we have specific thresholds for unusual. And in the context of this chapter, it's less than 5. Yeah, here they have it right here. Less than 5%. So if your probability is less than 5%, then you are unusual. Okay. If your probability is greater than 5%, excuse me, you're not unusual. So the probability of having 0 HD televisions is 3%. 3% is less than 5%. So that is unusual. Okay. Also, make sure that you're getting more and more comfortable with seeing decimals and turning them into percentages, right? To go from decimal to percent, you take the decimal and you move to the right 2 places, right? So this is 3%. This is 16.2%. This is 25.9%. And this is 54.9%. Right? So you want to make sure that you're comfortable doing that. Okay. All right. Number 6. The probability that a house in an urban area will be burglarized is 5%. If 20 houses are randomly selected, what is the mean of the number of houses burglarized? Okay, so we have a formula for that, right? Let me see where it is in my notes here. Here we go. The mean is your n times your p, okay? So let's start labeling things here, okay? We have, first of all, let me write out the formula. So we have 20 houses, that's our n, okay? Then we have a p of 5%. So we need to change from percent to decimal. When we go from percent to decimal, divide by 100, or you can say move the decimal, that's an E, to the left 2 places, right? Kind of undoing what we did in the last one. So you can either plug it into your calculator, 5 divided by 100, right, percent per 100 to get 0.05, or just get comfortable moving your decimal over. So our P is 0.05. Now, they didn't ask for it, but quick reminder, if we wanted to find Q, Q is 1 minus P, right? So that would be 1 minus 0.05. So that would be 0.95. They didn't ask for it. We don't need it for this formula, but you just want to make sure you're comfortable getting that for when you do need it. Okay, so the mean is n times p, n times p, and that's how they're getting 1. Okay, the mean of the number of houses burglarized. So the mean number of houses burglarized is 1 in 20 randomly selected houses. Okay. All right, number 7. According to government data, the probability that a woman between the ages of 25 and 29 was never married is 40%. In a random survey of 10 women in this age group, what is the mean and standard deviation of the number that never married? Now, from what I've seen, most of the time, when they give you a particular number, a percentage, they're giving you what they're later going to ask for. But just be aware that that's not always the case. I think in most of the problems that they give you, it's going to be the case, but just be aware that just because they gave you the percent that were never married doesn't mean that they can't ask for the percent that were, or I mean the probability or the mean or whatever of those who were. So they might give you one and ask for the other. So just always be aware of that. So for instance, in the last one, they gave us probability that a house will be burglarized, and then they asked for the mean number of houses burglarized. They could have given us the probability of being burglarized and then asked for the mean number of houses not burglarized, right? So that's why we might need to know Q if they're going to ask us for the other thing. So just be aware of that. Okay, so again, let's go through and let's get our formulas and let's label everything and we'll plug everything into our formulas. So again, our mean is n times p, and then our standard deviation is going to be the square root of n times p times q. So we're going to have n and p and q. So we're going to have to label all those, and then we can plug them into our formulas. Okay. All right. So this, I'm just going to go in order of what they give me. So I'm going to label this is p, is 0.4 or 40, if that kind of helps you remember that that's 40%. You don't have to have that 0 at the end there. The survey is of 10 women. And so they haven't given us Q, but again, we can find it ourselves because it's just the complement of P, right? It's 0.6, right? Okay, so again, let's write out our formulas. I'm going to do one thing at a time here. N times P. And then if you wanted to, you could plug this into the calculator, but we're multiplying by a factor of 10, so that just moves the decimal to the right one place. So that's just 4. Okay. And then our formula for standard deviation is the square root of N times P times Q. So we have N times P times Q. So I'm just going to plug that into the calculator. Remember, for your square root, the symbol is right here above the x squared button. To get that symbol, you hit the second and then that button. So square root of 10 times 0.4 times 0.6. And we get that number, which, if we round to 2 decimal places, is approximately 1.55. Okay, so you need to know these formulas so that you can use them when you're asked this. Again, I like to box in my formulas in my notes just so that they're, easy for me to remember. When I'm scanning through my notes, I can find them quickly. Like I said, I'll give you a PDF of those notes. Okay, in a recent survey, 63% of the community favored building a police substation in their neighborhood. If 14 civilians are chosen, find the probability that exactly 5 of them favor the building of the police substation. Round the answer to the nearest thousands. Okay, so 2 things. There is a formula for this, right? This is the formula, which expanded looks like this, okay? It's important that you know that there's a formula, because if we were asked to do this by hand, we absolutely could do that. But we're not being asked specifically to do it by hand, so we're going to do it in the calculator, okay? So I've said this many times in many ways, but part of this class is you guys being taught that there is a formula, right? These formulas were created very long ago, and we can absolutely do them by hand. And another part of this class is you guys learning how to use the technology that we have available to us, okay? So when you're taking a test, unless it's specifying that you have to do something by hand, your instructor is working off of the assumption that you're using the calculator. Okay, so you want to make sure that you know how to use the calculator. There's nothing wrong with doing this by hand, but in a test, they're saying, okay, it's going to take the student X number of minutes to do this problem. They're calculating that based on you using the calculator, not you doing all this by hand. Okay. All right, so let's start labeling some things, shall we? Okay, we have okay, 63% of the community favored something. Okay, so that's P is 0.63. 14 citizens, here, let me circle all the things we're writing down. 14 citizens are chosen. Well, that's our N, that's our sample size. Now, find the probability that exactly 5 of them. So this is going to be our X value. Okay, X is our exact. Now, when we're looking for exactly something, that tells us that we're going to be using binom PDF, okay? PDF as opposed to CDF, okay? So if we have exactly a certain number, that's PDF. PDF when we're looking for the exact value. Okay, so how do we get to that menu in the calculator? We're going to, let me write it out here. We're going to do second, and then the vars button, which above that has the word DISTR, distribution. right? Binomial distributions, that's what we're working with here. So we go second vars, and then we're going to either arrow down all the way to A, which is binom PDF, okay? Or instead of arrowing down, I go second vars and I can arrow up, and it sort of starts up at the top, or I'm sorry, when I go up, it starts down at the bottom of the list, okay? And I have binom PDF. Or let's say I've been doing a bunch of these problems and I remember off the top of my head that it's A. What I can do is I can say, well, I want to go directly to A. So A is in yellow here above the word math. B is in yellow above apps, right? You see the letters. If I want to go directly to A, I can say alpha A, right? If I hit the yellow button, it's going to do the yellow, kind of like the second button does what's in the sort of green color. Might be a different color on your calculator. So I'm going to say alpha math, and it goes directly to binom PDF, okay? All right, so second vars, and then we go down to A, binom PDF. Okay, so you have to remember that if we want exactly this number of successes, we're going to be doing binom PDF. Also, a quick reminder of what these actually mean, right? N is the number of trials, number of people. P is the probability of success in a single trial. Success is not necessarily a good thing, right? Success could be your house is burglarized, right? We're just talking about either success or failure. So P is probability of success, Q is the probability of failure, which is the complement of that, 1 minus P, and X is a count of the number of successes in that many trials, right? You could have 0 all the way up to all of them, okay? All right, so we've got our P, our N, our X. Okay, so now we're going to plug these in. So the calculator wants us to tell it the number of trials. Well, that's N. That's 0.63. It wants the P, which is the number of successes. Well, that's just P. That's 14. And it wants the X value. Well, that's our X, which is 5. So trials is, whoops, trials is not 0.63. I was looking up here. Trials is, oh my gosh, I did write that down backwards. See, and this is why you go slow instead of speed through. The number of trials, N is 14. The probability of successes is 0.63. All right. So N, the number of trials, 14, right? There are 14 citizens that are chosen. The probability of success, which is that they favor the building of the substation, is 0.63. The X value, what we're looking for, the exact number of successes that we want, that's 5. Okay, so that's what goes there. Now, when you see this on your calculator, if you have a calculator like mine, I have a nice pretty purple one. It's the TI-84 plus CE. Actually, I don't know if you can see that because of the reflection. I used to have a TI-83, and it could do this as well, except that when I went into the binom PDF menu, it didn't prompt me with these things. It didn't say, hey, tell me the number of trials, tell me your number of successes, tell me your X value. It didn't prompt me with that. All it did was give me this, and I had to know that I have to plug them in the order NPX. I had to memorize that, okay? So if you have an older calculator, if it's not the 84, if it's the 83, you can still do this. Even though your menu looks a little different, it's still going to work. You just have to have that extra step where you have to memorize that you have to put the numbers in this order. So you put in your N, and then you put a comma. Your comma button is right here. And then you put in your P, and you put a comma, and then you put in your X, and then you close your parentheses, and then you can hit enter, okay? And when we round that to 3 decimals, we get that number right there. And actually, I'm going to go ahead and write binom PDF, and we put it in the order NPX. Right? Okay. So again, this is something that I've highlighted in yellow because this is how we do it in the calculator. When we're looking for exactly X number of successes, it's second vars, A, alpha, which is binom PDF in the order NPX. Okay. All right. Number 9. probability that a tennis set will go to a tiebreaker is 14%. What is the probability that 2 of 3 sets will go to tiebreakers? Round the answer to the nearest thousandth. Okay, so 2 of the 3 sets. So what's another way to say that? Exactly 2. I want to know the probability, or they're asking for the probability that exactly 2 of the sets go to tiebreakers. So because we can word it that way, because we can think of it that way, that's what's telling us that this is going to be binom PDF, right? P is in Papa. So again, let's go through, let's label things. Now, because I end up accidentally writing my P where I should write my N, I'm going to go ahead and write them in the order I know I need to plug it into the calculator, just to save myself from making that mistake. And let's go through and label things. So probability that it'll go to a tiebreaker is 14%. So that's P. So that's going to be written as a decimal, right? You always take your percentage and write it as a decimal. It's 0.14. The probability that 2 of 3 sets. Okay, exactly 2, that's our X. Exactly 2. Well, what's our N? Our N is 3. There are 3 sets, and of the 3 sets, we want to know the probability that exactly 2 will go to this tiebreaker. Okay? So again, in our calculators, we're going to go second vars. We're going to either arrow down or arrow up to go to binom PDF, or we can just go directly there using the alpha. And I'm going to plug in my trials as my N, that's 3. Probability of success, 0.14. And the exact number of successes that I want is my X value, and that's 2. So I hit enter, and it says, okay, I've set everything up, and we hit enter again, and it does the calculation for us. Again, if we wanted to do this by hand, we could by doing this whole formula, or we could just do that. So let's just do that. Again, unless your professor specifically has problems where they want you to do it by hand, which is great because it kind of gives you a feel for like how much work this used to take before we had the calculators, right? Okay. All right, a survey asks 1,500 workers, has the economy forced you to reduce the amount of vacation you plan to take this year? 52% of those surveyed, so I'm going to start circling things that we're going to be writing down. 52% of those surveyed said they are reducing the amount of vacation. 10 workers participating in the survey are randomly selected. The random variable represents the number of workers who are reducing the amount of vacation, which is good because that's the percentage that they gave us. Decide whether the experiment is a binomial experiment. If it is, identify a success, specify the values of n, p, and q, and list the possible values of the random variable x. Okay, so what does it take for something to be a binomial experiment? So I have this somewhere in, here it is. In the notes here, what does it take? It takes a fixed number of independent trials. So do we have that? Yes. Also, this is on page, I have somewhere else in my notes, I wrote that this is on page 201 in your book. Okay, so a fixed number of independent trials. Yes, it's a fixed number. We're only taking 10 workers in this trial, or each trial is one person, and we're only doing it 10 times. That's fixed, 10 times. Okay, only 2 outcomes for each trial, either success or failure. Yeah, either they answered yes or they answered no to the question. Probability of success is the same for each trial. Yes, because they've already established what that probability is. Okay, they've already said that out of the whole 1,500 workers, 52% of them say yes. That's already been established. And then the random variable x is the number of successful trials. Yes, this, well, they haven't specified here that question, but that's what x is going to be. Okay, so is the experiment a binomial experiment? Yes, because 1, 2, 3, 4, check, 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 check. Okay, what is a success in this experiment? is selecting a worker who is reducing the amount of vacation, because that's the probability that they've given us. 52% of those surveyed said they are reducing the amount of vacation. Okay, specify the value of n and select the correct choice below, fill in any answers. Okay, so some people might get confused here because they might say, well, I have 1,500 workers. So that's what you started with, but then of that, so that 1,500 was used to come up with this, okay? Once you have this, then we're taking 10 of those 1,500. This is our n, okay? See the difference there? So yeah, we started with 1,500, but we're going to only look at 10 of them and do some stuff with 10 of them, okay? So that's why our n is 10. Okay, the value of p, they told us the probability of a success is 0.52, is 52%. The value of q, so hopefully you can do that in your sleep, that the value of q is the complement of p. So the value of q is 1 minus 0.52. That's going to be 0.48, right? If 52% say yes, then that means 48% said no. So that's how they're getting 0.48. And then list the possible values of the random variable x. So they're saying what are all the different options you can have here? So let's go back to number, what is it? Was it number 3? Yeah, here we go. Number 4. So if we look back at number 4, the probability distribution of the number of overtime hours worked in 1 week per employee. So they either had no overtime or 1 or 2 or 3 or 4 or 5 or 6 hours. Those were all of my possible values of x. Okay, that's all I had. So with this, when we're looking at the number of successes, well, we have 10 people, right? Oops, goodness, such violence. Okay, I was trying to get this to remind you that the x's are a count of the number of successes in n trials, and x can be anywhere from 0 all the way up to n. Don't forget 0. It is possible to have 0 successes, okay? So that's why if we have 10, I want to get the whole thing in here. If we have 10 workers that are participating in the survey, either 0 of them could say that they are reducing the amount of vacation, or maybe one of them says it, or 2, or 3, 4, 5, 6, 7, 8, 9, 10. Those are all the options that we have for x. Those are the possible values of the random variable x, because we go from 0 all the way to whatever our n value is, which we established was 10. Okay, so don't forget 0. Okay. And then I don't know why I have a blank page. All right, 59% of US adults think that civil rights for Black Americans have improved during their lifetime. You randomly select 8 US adults, find the probability that the number who think that civil rights for Black Americans have improved during their lifetime is A, exactly 3, and B, exactly 6. Okay, so we talked about this in the previous problem, where if we're trying to do exactly, then that means that we're doing a binom PDF, NPX, and that's the A option when we do second vars, DISTR distribution, binomial distribution, second. Sorry, I'm not used to working backwards. All right. So let's start labeling things, okay? So 59%, okay, that's going to be, I'm going to work this down here. 59% is RP, 0.59. You randomly select 8 US adults, that's our N. Find the probability that the number, find the probability that of that for exactly 3 our x value is 3. Okay, so this is for A. So we're going to go second vars. I'm going to do the alpha math to go directly to A. So my n is 8. Make sure I don't mix these up this time. My p is 0.59. And I'm saying I want exactly 3 people to be successes. So that's how we're getting rounded to 3 decimals, 0.133. Now for B, they want exactly 6. So everything else is going to stay the same. My n, I'm going to put them in the right order this time. My p, but my x, my number of successes, is going to go from 3 to 6. Okay. Cool little thing that I learned how to do this semester. I could go back into the second vars menu, or if you arrow up and you highlight the thing that you had and you hit enter, it'll like copy and paste it. And you can go in and you can say, okay, well, instead of 3, I want to change that to 6. And then you can hit enter. So that's kind of a cool thing that you can do. Or you could just go back and do second, vars, arrow down, or arrow up, or go directly to it and then plug in the 6 there. Either way, when you round to 3 decimals, that's what you get. Always good to do a rounding refresh. 0.198535357. They want us to go to 3 decimal places as needed, 1, 2, 3. So you underline the place that you're going to round to. You look to the number to the right. If this is 5 or more, then the number you've underlined goes up 1. If this is not 5 or more, so if it's 4 or less, this number stays the same, and then everything else goes away. So this number is 5 or more, so the number that I've underlined goes up 1. So that's how we get 0.199. Okay. All right, so switching to a different kind of question here. Find the area under the standard normal curve to the left of this z-score. Okay, so we're going to do this 2 ways. We're going to do this in the calculator, and we're going to do it using the chart, using the table. So first of all, we want to kind of picture what's happening here, okay? So we have standard normal curve, okay? Remember that in the standard normal curve, your mean is in the center. Don't necessarily need to write that. Z-scores are positive to the right and negative to the left. This is a z-score of 1.25, so we're to the right 1.25 standard deviations, because remember that's what a z-score is the number of standard deviations away from the mean you are. So this is a z-score of 1.25, and they want the area under the curve to the left, so they want this area. Remember that the area under the whole curve is 1. Okay, the area under the whole curve is 1. They want the area to the left of that. So there's 2 ways to do this. Either we look in the book. Where have I put? Oh, there's my book. Like I put it right here so that I could have it right in front of me. All right, so we go to the back of the book and we go to our table 4, okay, standard normal distribution. And in the table, we have our z-scores are the numbers along the outside. The areas are the numbers on the inside. Now you'll notice the first page here, these z-scores are all negative because these are the z-scores to the left. So we have to go to the other page that give us positive z-scores because we're looking at the area to the right. So we were looking at a z-score of what now? 1.25. Okay, so we're going to say z-score of 1.2, and then we're going to go to the right until we get to 0.05. Right, 1.25 is 1.2 plus 0.05. So we have 0.8944. Right, so that, and then that's the answer. That's it. That's all they're asking for. The area under the curve to the left of that, 0.8944. Okay, or we could do this in the calculator. Okay, so if we want the area, so either look up in table, and they might provide you with a table, okay, or use the normal CDF, okay? So let's take a look at what that looks like. So that is going to be in same menu that we've been in. We're going to go second, vars, and it's this second one right here, right? So we go second, vars. I'm not going to write this every time. And then we go down to number 2, which is the normal CDF. Okay, now when we get into this menu, we have a few things happening here, okay? We've got a lower bound, an upper bound, a mean, and a standard deviation, okay? So similar to the binom PDF that we were doing earlier, if you have an older version of this calculator, so instead of an 84 and 83, again, it's not going to prompt you for these. It's just going to have you have to know what numbers you're putting in what order, and you have to separate them with commas. So what we're putting in is our lower bound. I don't know why I wrote that so high. Our upper bound, our mean, and our standard deviation. Now, when you're dealing with z-scores, so if you are given a z-score, not an x value, but a z-score, you need to use a mean of 0 and a standard deviation of 1. That's what you have to plug in into the calculator here. Mean of 0, standard deviation of 1. If you plug in something else to the mean and standard deviation, you're not going to be getting a z-score. You're not or I'm sorry, you can't mix and match, okay? Either you have an x value or you have a z-score. So if you have x values, you can plug in whatever your mean and your standard deviation are. But if you have z-scores, you need to plug in the 0 and the 1 for this chapter. Okay, so what are we talking about lower bounds and upper bounds? We're talking about where it is shaded, okay? So this is shaded to the left. So technically my lower bound is infinite or negative infinity because it's way over there. It technically never ends, but we can't type that in. So we have to give it a really, really, really low number. Okay, so you'll notice in the calculator, it defaults to this -1e99. So you might say, well, if that's not there, how do I plug that in? You can use -1 times 10 to the 99th for your lower bound. And you can use +1 or just 10 to the 99th for a positive upper bound. So like if we're shading, let's say we're being asked to do that, this would be our lower bound. Our upper bound would be 10 to the 99th. We want to choose a really, really big number or a really, really small number, like a negative, I mean. So -1 times 10 to the 99th. That's the lower boundary of our shaded region. The upper boundary of our shaded region is this z-score. Okay, so we put in the z-score, and because we're using a z-score, we have to have our mean and our standard deviation as 1. Okay. All right, so my lower bound, I'm going to leave it -1e99, or if it wasn't written there, I would do -1 times 10 to the 99th. My upper bound is the z-score that I've been provided, 1.25, and I'm going to leave my mean and my standard deviation as 0 and 1. So again, this is what it would look like if you had the TI-83, where you just plug the numbers in, separating them with a comma, in the order of lower bound, upper bound, mean, standard deviation, and then we hit enter. And again, if you round that to 4 decimal places, as all of these answers are, you're going to get 0.8944. So I know I took a while to explain how to do it in the calculator, so it may have felt like it was longer to do it in the calculator. And to be honest, it may have actually taken a little bit more time, even if I wasn't explaining it, to do it in the calculator. rather than looking it up in the table. So for each problem that you get to, you need to decide for yourself, hey, what's going to be faster for me to do? Also depending on what you're most comfortable with. Having said that, you need to know both ways, right? You need to know how to look things up in the table, and you need to know how to do this in the calculator. You need to know both. Okay, and then did I have, I think I had, yeah, so I do have this here, how to do it in the calculator. So in the calculator, you do second vars. We're doing normal. CDF is the area under the curve, lower bound, upper bound, mean standard deviation. We either have -1 or +1, 10 to the 99th. If you're using 0 and 1 as your upper and lower bounds, you're working with z-scores. But if you're not using those, you're going to be given X values, or you need to give it X values for the bounds, right? So your bounds are either z-scores or your bounds are X values. Okay. And also remember that in the table in the back of the book, it will only give you the area to the left of the z-score. Okay. We're going to be doing some problems where we're looking at stuff to the right, so we'll deal with that when we get to that. Okay, perfect example, area to the right. So there's two ways to do this. So one way is to kind of just go through the same process that we just went through, right? So it's always a good idea to kind of sketch what you have happening. I'm a very visual learner, so the sketching is super useful to me. I have a z-score of -1.25, so my mean is right here in the middle. So I go 1 1/4 standard deviations to the left. So that's a z-score of -1.25, -1 1/4. And they want the area under the curve to the right of that. Okay. So they want that area. So if I'm going to look this up in the back of the book, I'm going to start by looking up this z-score, but what the book is going to give me is this area. I don't want this area, I want this area. So that's where I have to remember that the area under the whole curve is 1. So I can do 1 minus the unshaded region will give me the shaded region, right? So let's go ahead and do that, because again, we're going to do it both ways here. So in the back of the book, I have a negative z-score, so I'm going to look at this table. It was -1.25, so -1.25. Where do those overlap? Right here at 0.1056, right? Do you see that? -1.25, so 0.1056. Okay, so the unshaded region is 0.1056. So in my calculator, I say, well, what's the complement of that? What's 1 minus 0.1056? It's 0.8944. So the shaded region is 0.8944. Okay. Now, if I were to do this in my calculator, we're going to be doing normal CDF. I have my lower bound, so the left boundary of the shaded region, that z-score is -1.25. My upper bound is the upper boundary of the shaded region. That's 1 times 10 to the 99th. My mean, because I have z-scores for my boundaries, my mean is 0 and my standard deviation is 1. So normal CDF, second vars, and I can just press number 2. So I have -1.25. My upper boundary is 1 times 10 to the 99th, and I leave that as 0 and 1. So if I take that answer and I round it to 4 decimal places, I get 0.8944. Now you might look at these and you might have noticed right when we got 0.8944 that number looks familiar. You might say, well, wait a minute, wasn't that what we got on the last one? It sure is, right? So look at that. If I have a positive z-score and I want the bigger section, I get the same number as if I have the negative z-score and take the other section, right? Because these are the same distance away from the mean, right? This is 1¼ to the right of the mean. This is 1¼ to the left of the mean. So it makes sense that the area to the right of the negative and the area to the left of the positive are going to be exactly the same. Okay, so you want to make sure that you're kind of comfortable with the idea of how these are all related. Okay. Find the area under the standard normal curve between a z-score of 1 and 2. Okay, so mean is right in the middle, z-score of 1, z-score of 2, right? That's z equals 1, that's z equals 2, and we want the area in between them, okay? So what you're going to do is you're going to say the, well, I guess I'll just kind of draw it. If I start with the z-score of 2, and I find the area to the left of that, okay? And then I say, okay, great. Now I want to get rid of this portion, right? I don't want that anymore. That will leave me with that middle portion. So that's exactly what we're going to do. We're going to do the area to the left of z equals 2 minus the area to the left of z equals 1, right? So again, in the back of the book, say, all right, what's a z-score of 2? 2.00? That's going to be 0.9772. And the area to the left of a z-score of 1, 1.0 is 0.8413. Okay, and I'm going to take those and I'm going to plug them into the calculator. And that's how we get 0.1359. So that's what I would do if I was doing it by hand. So if I want to do it in the calculator, I can still use what we've been using, right? I can do normal CDF, right? So that's one way. Another way is the normal CDF. My lower bound is 1. My upper bound is 2. My mean is 0. And my standard deviation is 1. Second vars, the second option, so number 2, normal CDF, lower bound is 1, upper bound is 2, leave our mean and standard deviation as 0 and 1, and we're getting the same number. Another thing that you could do, not that you have to, but you guys remember the 68, 95, 99.7 rule, right? Where we have that if I go 1 standard deviation out on either side, that's 68% of the data. And if I go 2 standard deviations out, that's 95%. And if I go 3 standard deviations out, that contains 99.7. Right? We learned about that in one of the previous chapters. So 1 standard deviation to 2 standard deviations, that's this right here. So if I were to take this area, the 95%, and subtract from it this area, the 68%, that would leave me with these two portions right here. This rectangle and this, I mean, it's not really a rectangle, but these two areas right here, it would give me that. So if I then cut that in half, it'll give me just one of them, right? So if I do 95 minus 68 and then cut that in half, it's about that. I mean, they're not expecting you to do that, but that's just a reminder that that's how that works. Okay. Find the area under the standard normal curve between those two values. So I'm not going to do this in the using the table. We're just going to do it in the calculator. Normal CDF. Our lower bound is negative 1.5. So again, it's always a good idea to draw. I have a z-score of negative 1.5, and then I go 1, 2.5, a z-score of 2.5, and I want the area in between them. Okay, so my lower boundary is 1.5. My upper boundary, I'm sorry, negative 1.5. My upper boundary is 2.5. My mean is 0, and my standard deviation is 1 because these are z-scores, not x values. So again, the menu for normal CDF is second vars, and then the second option, negative 1.5, 2.5, 0, and 1. And that's how we're getting 0.92. Again, if we round, we'll get that exact number. Okay. So you can see how quickly you can go through these types of problems if you do them in the calculator. Okay. All right, find the probability of Z occurring in the indicated region. So they're specifically giving you the tables, so we're going to specifically use the tables. So they've kind of worded this a little bit differently this time. They're not just saying what's the area under the curve, they're saying the probability of the z-score occurring in the indicated region. Well, that is the area under the curve, right? The area under the curve is the probability of something happening in that region, right? That's the connection here. So we're going to go ahead and use the table. So we have a z-score of 1.82. All right, so they give us this, which is not helpful. Well, not that it's not helpful, but it's not useful in this problem because these are all negative z-scores, right? Negative z-scores occur to the left of the mean. We're to the right of the mean, so we're not going to look at the negative. We're going to look at the positive. And we're looking for 1.82. So we're going to go 1.8. Let me grab my highlighter here. Sometimes if you can write on these, again, I'm visual. I like to do that. I have 1.8 is right here, is this row. And then the 0.02 is this column right here. So where they intersect is going to be the area to the left. So that's how we get 0.9656, right? 0.9656. Or if we were doing this in the calculator, we would do normal CDF. Our lower bound would be negative 1 times 10 to the 99th. Our upper bound would be 1.82. Our mean is 0, and our standard deviation is 1, and we would get the same thing. But they wanted us to use the table specifically, right? They want to make sure you know how to use both of the tools at your disposal, the table and the calculator. Okay. All right, find the probability of Z occurring in the indicated region. Same process here, right? We have the area to the left, right? So we can look up in the table. We're looking for a negative 0.59, negative 0.59. Oh, I didn't print out an extra one. Let me go back to here. Nope. Where is the page? There we go. Negative 0.59 is the z-score we're looking for. So negative 0.5, and then the 0.09 is here. So where they intersect is 0.2776. And there we go. And again, second vars, and then the second option, normal CDF. Our lower bound is negative 1 times 10 to the 99th. Our upper bound is negative 0.59, mean of 0, standard deviation of 1, if we were to do that in the calculator, and we'd get the same answer. Okay. Same thing here. I'm sorry, not same thing, slightly different. Probability of it occurring in the indicated region, and they've shaded to the right. So remember, what we look up in the table is going to give us the area to the left, and that's fine because all we have to do is do 1 minus the area to the left. and that will give us the area to the right, because the area under the entire curve is 1. Okay, let's see, I don't think I printed out. No, I didn't print it out. That's fine. We'll just use the same tables. Let me just pull these out so I can keep coming back to them. So a positive 1.75. Let me use a different colored highlighter. All right, positive 1.75. So we're going to go to the table and we're going to go 1.7 is here, and then the 0.05 is here. So where the oranges intersect is 0.9599, and you'll notice that 0.9599 is one of the options here, right? They want to make sure that you're paying attention and that you're not just blindly finding a number and plugging and, selecting it, because they didn't ask for that. Because remember, that's what this gives you. This table only gives you the area to the left of Z, and that's fine. It gives us the information we need to find what we're actually looking for. The area to the left is 0.9599. So we can just do 1 minus 0.9599, and that's how we get 0.0401 is the area to the right. Right? This shaded area here is 0.0401, and this whole area here, all of that is the 0.9599. Okay? I mean, not just what I've circled, everything besides the shaded. And again, if we wanted to do this in our calculator, we would do second vars, normal CDF. Our lower bound is 1.75. Our upper bound is 1 times 10 to the 99th. Our mean is 0. Our standard deviation is 1. And we would get the same value because we've told it we don't have to do any 1 minus because we've already established this is my lower bound, this is my upper bound. Okay. Find the probability of Z occurring in the indicated region. And again, they've given us the table. So again, let's pick another highlighter color. And so we did a problem similar to this before. We want in between these two. So we're going to do the area to the left of the one that's farther to the right. So we're going to do the area of this. And from that, we're going to subtract this area, and that's going to leave us with that. So the area to the left of Z equals 3. From that, we're going to subtract the area to the left of Z equals -2, right? Okay, so Z equals 3. Right, so that's going to be 0.9987 minus Z equals -2. So let me go to my negative Z's. -2 also, you notice how I was about to highlight over here because you'll notice that they're in a different order. You have 0.09 all the way down to 0.00, whereas on this one you have 0.00 all the way up to 0.09. Right? So just be aware of that as you're using your table. Right? You don't want to kind of like get into such a sort of rhythm that you're not actually paying attention to what you're highlighting. I have totally done that before, so watch out for that. All right, so and then the area to the left of -2 is 0.0228. Okay, and we plug that into the calculator. And we get 0.9759, or again, another way that we could have done this is second vars, and then normal CDF. Our lower bound is -2, our upper bound is 3, our mean is 0, and our standard deviation is 1, and we would have gotten the exact same value. Just to prove it to you, let's do that. Second vars, normal CDF, lower bound -2, upper bound 3, 0, 1. Do we get the same thing? Yeah, if we round, we get the same thing. All right. Probability of Z occurring in the indicated region. Same process, right? Just because this is a Z-score of 0 doesn't mean it's not the same process. We're going to do area to left of Z equals 1.5. From that, we're going to subtract area to left of Z equals 0. All right, Z-score of 1.5. I'm running out of highlighter colors. 1.5. It's going to be positive 1.5, 0. Where do those intersect? 0.9332. And then here, for the area left of a Z-score of 0, you could absolutely look that up on the table. But what you're going to find is that it gives you 0.5. Because remember, a Z-score of 0 means that you are at the mean. And the mean is what separates the bottom 50% from the top 50%. Right? So the area to the left of the mean is half, 0.5. The area to the right of the mean is half, 0.5. So we don't even have to look that up. We just know that it's 0.5. But if you forgot that and you went to look it up, you would say, okay, 0, 0, oh, look, it's 0.5. Or even if you were looking at the other one and you say 0, 0, oh, look, it's 0.5. Right? So even if you forget it, you'll still get the same thing. It'll just save you a little bit of time if you do it that way. All right, so we got 0.9332 minus 0.5 or 0.50, however you want to think of it, 50%, you're getting 0.33, I'm sorry, 0.4332. Okay, so hopefully after you do a few of these, you start to feel pretty confident with them. It's the same general process every time. Okay, area to the area of the shaded region, it's the area to the right. And then again, we have a table. We could look that up. We could do 1 minus what the table gives us, area to the left of Z equals 1.36, right? Or we could just normal CDF it. Our lower bound is 1.36. Our upper bound is, we can't say infinity, so we say 1 times 10 to the 99th. Mean is 0, standard deviation is 1, right? Let's just do it that way. Now, some people might say like, oh, I just want to put like 10,000. Well, I mean, for the purposes of rounding, you'll probably be fine, but I like to just be extra, extra sure. And that's why I do such a large number. Also because that's what I was taught when I took this class back in the dark ages, forever ago. Either way you do it, you're going to get the same answer, 0.0869. Again, same thing. We can look this up in the back and from it subtract what we get when we look that up in the back, or we can normal second vars, normal CDF, our lower boundary, our upper boundary, our mean, and our standard deviation. I'm kind of flying through these because it's all the same thing, and we have some different types of problem coming up at the end that I want to make sure that we get to. Right, 0.7881. Okay. Okay, so here we go. Slightly different type of problem. For the standard normal curve, find the z-score that corresponds to the 90th percentile. Okay, so we have to remember, what does the 90th percentile actually mean, right? So again, kind of drawing our curve here. So the 90th percentile means that it's what separates the bottom 90% from the top 10%, okay? That's the 90th percentile. They want us to find what's that z-score. So instead of being given a z-score and being asked to find the area, either to the left or to the right, in between, we're doing it the other way. We're doing it the inverse way, you might say. So instead of being, actually, let me write this out. If you're given z-scores and you want to find the area, that's normal CDF. But if it's the other way around, if you're given an area and you want to find a z-score or an x, oops, sorry, you can't see that, or an x value, which you would need to first find the z-score to then find the x value, you're going to do inverse norm. Okay, so you can kind of think of that like, oh, I'm doing the inverse of what I did before. Okay, so we're going to do this both in the calculator and by hand. Let's start in the calculator. Normally I start by hand, but let's start in the calculator on this one. So same process as before, or same menu. We're going to go second vars, because second vars is distributions. Second vars, and number 3 is inverse norm. All right, you see that? Number 3, inverse norm. So 3 INV norm. Okay, now if you have the nice pretty fancy calculator like me, then it is going to prompt you with all sorts of things. It's going to ask you for the area, the mean, the standard deviation, and it's going to say, hey, where is this area occurring? Is this area to the left of a value, in between two values, or to the right of a value? If you have the TI-83, if I remember correctly, you don't get these options. You're only able to give it the area to the left, and you just have to always give it the area to the left. Even if you weren't given the area to the left, you have to first find the area to the left and then give it the area to the left. Okay, so let's see what we're plugging in here. So what is the area? So they said the 90th percentile. So let's pretend we didn't do the math to say that, well, if this is 90%, then that means 10%. Let's pretend we didn't even do that. All we have is what we were given is the 90th percentile. So that's 0.9, or you can say 0.90 if that makes you feel more comfortable. We're leaving our 0 and our 1 as they are, and we have to make sure to tell it that that area that we told it about, the 90%, that's to the left of the value we're trying to find. The value we're trying to find is a z-score, which is why we're leaving our mean and our standard deviation as 0 and 1. And then we arrow down, we say paste, and then enter. And that's our z-score. And it's as easy as that, right? Go to the correct menu in the calculator, make sure you're giving it the correct information, that you're giving it the area to the left, and then have it calculated. Okay, so what if we were doing, if we were using the table? Okay, so before, when we were using, okay, I do have the table here. So before, when we were using the table, we found a z value and we said, okay, where does that intersect? And we found our answer in the body. Well, now it's the other way around. We have to find the area in the body and then look to the outside to see what it corresponds to. Okay, so we're looking for an area of 0.9 because that's the area to the left and that's what the table gives us, right? The table always gives us the area to the left of whatever z-score it's looking at. So we need to say first to ourselves, well, which table should I be starting to look at? Should I start to look in this table? There's a lot of numbers here. Should I look here or should I look here? Well, is my z-score going to be negative or positive? If 90% of the area is to the left, I know my z-score has to be to the right because 90% is more than 50%. Remember, right here in the middle is our mean, which is the 50% of the area is to the left and to the right. So if I'm more than 50%, I've got a positive z-score. So I'm going to go to the page that has my positive z-scores, and I'm going to find in the body, excuse me, of the table, I'm going to find the number that's as close as I can get to 0.90. So let's find that together. So I'm looking here, and also keep in mind when you have 0.9 or 90, you can stick a bunch of zeros after it, right? So I can think of this as 9,000, and I can say, well, what's closer to 9,000? 9,015 or 8,997? Well, this number is only 3 away from that, whereas this number is 15 away, right? So if you're having trouble with the whole decimal thing, just ignore the decimals and pretend like it's 9,000, and you'll be able to see, excuse me, that this is the number that is as close as we can get using the table to this. So we say, okay, well, if that's my area, what z-score does it correspond to? And that's how we get 1.28, which, is it this one? I just moved the question. That's how we get 1.28 if we're doing it by hand. Okay? Right, so you can either, if you're given the area, you can find the z-score by doing inverse norm, or you can look it up in the body of the table, right? The area is in the body, and then you find your corresponding z-score on the outside. Okay. All right. Use a standard normal table to find the z-score that corresponds to the 5th percentile. So again, we say, okay, well, what does that look like? The 5th percentile. Well, the 5th percentile is the bottom 5% from the top 95%. Again, you don't have to do that math. We're just looking at the bottom 5%. What is the z-score that separates the bottom 5% from the top 95%? So that's going to be a negative z-score, right? We're all the way down here. We're really far to the left. So also if you're, I don't know, I guess just kind of general test taking strategy, you know that you can rule out this and you can rule out that. A z-score of 0 would be right in the middle. That would be 50%, not 5%. So we can rule that out. 4, well, that's really far to the right. That's positive. We can rule that out. So we've got these two negative values. So we're going to say, we're going to do the table as well, but we are given an area. We need to find a z-score. Therefore, we're going to do inverse norm. Okay, so we go second vars, and inverse norm is the third option. The area to the left is 0.05, and we make sure that it says area to the left, and that's how we get negative 1.645 if we're rounding to 3 decimals. Quick note here, if you really wanted to, you could, I don't know why I redrew that. The area to the right is 0.95. So I could go back into inverse norm and I could say 0.95 and tell it that that's the area on the right. And I'm going to get the exact same value, right? Because the area on the right of 0.95 and the area on the left of 0.05, that's the same z-score. So that's why I'm getting the same value when I do it either way. All right, so let's do this on the table. This is going to be a negative z-score. So I'm going to get my negative values here, and I'm going to look for 0.05. Okay, so we're trying to find where we have. Okay, so what we're seeing here is, and again, you can 0500, right? You can think of it as 500 because we're going to 4 decimals because everything here is 4 decimals. And I can say, well, I don't have exactly that, but what I do have is 505 and 495. Well, those are exactly the same distance away from 500, right? That's 5 away, that's also 5 away. So what I want is actually the number directly in between those two. Okay, so if I look at my z-scores going out and directly in the middle of these two, right? You see that? So I have negative 1.6, and then I want the value that's directly in between 0.04 and 0.05. That's going to be 0.04 and half more, right? So that's a negative, negative 1.645. Okay, so that's how you would do those if you're doing them on the table, right? If they're exactly the same distance away, you do the number in between. Halfway in between 0.04 and 0.05 is 0.045. Excuse me. So yeah, sometimes you know, you get those. Oh, that's what I was going to say. If you're exactly the same distance away, then you have to do the number in the middle. But if one of them is closer, then use the one that is closer, like we did on a previous example. Okay. All right. So slightly different type of problem here. The body temperatures of adults are normally distributed. Well, that's good. Normally distributed. With a mean, okay, we got a mean of 98.6. Okay, great. Standard deviation, great. 0.72 degrees Fahrenheit. Those are both in degrees Fahrenheit. What temperature represents the 95th percentile? So they're asking for an X value. They're not asking for a Z-score, they're asking for an X value. What temperature? Okay, so let's take a look at, well, what is the 95th percentile on the standard normal curve? The 95th percentile is what separates the bottom 95% from the top 5%. Okay, they want to know the X value, the data point that separates that from that. Okay, so this is going to be a couple of steps because what we're going to do, we're going to do it a few different ways, but we're going to start doing it by hand. We're going to start by first finding the Z-score that separates these two things from each other. Okay, so we're going to, I guess maybe I'll label this one. Find the Z-score that corresponds to the given area. Okay, and then once we have that Z-score, we're going to use the formula to convert the Z-score, S-C-O-R-E, to an X value. Okay. All right, so that's how we're going to do it if we do it by hand. We'll do it in the calculator later. All right, finding the Z-score. So I have an area to the left of 0.95. So we're going to look that up in our chart. Did I save one of my charts over here? Those are negatives. Let me get a positive. All right. So we have, oh, you know what? Well, I was going to say we kind of just did this. I mean, it's not really cheating, but we're going to end up with here. Let's just pull this up here. So we're looking for an area to the left of 0.95. So we have 0.95. So we are, there we are. Oh, you can't see that. Losing my mind here. I'm like, where are these numbers? So 0.95 is directly in between, is exactly halfway in between these two. Now I'm just going to do this in pencil because I'm running out of highlighter color. Do I have another? Oh, I do have another highlighter color. Good. So I'm halfway in between those two. So where am I at? I'm exactly halfway in between these two. So that's 1.6. And then I have halfway in between 0.04 and 0.05 is 0.045. So that's 1.645. You don't have to actually like write it out this way. If you can just kind of see that, that's great. But I have 1.645. All right, that's my z-score. Great. Find the z-score that corresponds to the given area by looking it up in the chart, 1.645. Okay, now we're going to use the formula to convert the z-score to an x value. So what formula am I talking about? The z-score is x minus the mean over the standard deviation. Now, we can certainly plug our values in here to find this unknown value, or and when we do that, we have to remember some rules of algebra to then solve for the missing variable. Or if you're not feeling super confident with your algebraic rules, you can memorize the other formula, which is really just this formula rearranged. So these are the same formula, they're just rearranged so that the thing that's on its own is a different value, because sometimes you're looking for a z, sometimes you're looking for an x. Okay, we're going to do it both ways so that you can see what I'm talking about. So let's say that you're not super comfortable with your algebra and you want to just memorize this formula as well, because you're going to need to know both. So you will have to memorize this if you don't want to use this. Okay, so we're going to plug in what we know. We know that our mean is 98.6. We know that our z-score is, oh, I didn't leave myself any room here, is 1.645. And we're going to multiply that by our standard deviation, which is 0.72. Okay, so we put that into our calculator. 98.6 plus 1.645 times 0.72, and we get 99.78. Okay, if we round to 2 decimals. And then we have to remember that this isn't just a random number, this actually means something. What does it mean? It means degrees Fahrenheit. So we stick back our units onto our number, 99.78 degrees Fahrenheit. Okay. All right, now let's say that you don't want to have to memorize this and you're feeling okay with your algebraic rules. We're going to plug everything into here. So for z, I have 1.645. My x value is my unknown. My mean is 98.6, and my standard deviation is 0.72. All right, so let me get pink. To get the x value by itself, it's got a bunch of stuff happening to it. We need to undo those things. The first thing we're going to undo is that it's being divided by 0.72. How do we get rid of division? We do the opposite function. What's the opposite of division? Multiplication. So to get rid of dividing by 0.72, I'm going to multiply by 0.72. What I do to the right side of the equation, I have to do the exact same thing to the left side of the equation to keep it balanced, right? So if I multiply and divide by the same thing, they cancel each other out. And then on the left, I'm going to say, okay, 0.72 times 1.645. So over on the left, I have 1.1844. And on the right, I have x minus 98.6. Okay, so we almost have x by itself, but it's still got this minus 98.6 over here. Well, we don't want that. We want to get rid of it. So how do we get rid of subtraction? We add. We're going to add 98.6. What we do to one side of the equation, we do the exact same thing to the other to keep it equivalent. If we add and subtract the same thing, they cancel each other out because they're opposite functions. And over on the left, we're going to take our 1.1844 and we're going to add 98.6. And we get the exact same thing. 99.7844, which if we go to 2 decimal places is 99.78. Okay, so whether you memorize this formula or whether you just use this formula and just feel comfortable solving equations, you'll get the same thing. Okay, or when we were back here finding our z-score, instead of using the formula, what you can do is we go into our calculator, we go second vars inverse norm, and this time we're not going to give it z-scores. because we're not looking for a z-score, we're looking for an x value. Okay, so this is how we would do it if we're doing it in the calculator. So remember, if we have an area and we're looking for x's or z's, we're using inverse norm. So what's my area? I can either say that the area to the left is 0.95 or the area to the right is 0.05 because it's exactly the same value that separates them. So I'm going to say area 0.95. I'm going to jump real quick to the left just so that I don't forget that that has to go to the left. But then instead of the 0 and the 1, I'm going to plug in the values that I know. I know that my mean is 98.6. I know that my standard deviation is 0.72. So now when I go and I have the calculator give me this value, because I have given it the mean and the standard deviation, it spits out an X value rather than a Z score. Okay. So there's kind of like 3 levels that you can do this, because if you wanted to, you could actually still use the formulas. Like you could still find the z-score in the calculator and then use the formula, right? You could do it that way if you wanted to. So this is one way. Another way is find z-score in calculator, and then use formula, right? So what would that look like if I just found the z-score in the calculator? Well, that would be second var's inverse norm, 0.95. If I'm looking for a z-score, I need a mean of 0 and a standard deviation of 1. And I get 0.645. Okay, find the z-score in the calculator. Okay, my z-score is 1.645. If I round to 3 decimal, oh, you guys can't see that. If I round to 3 decimal, 1.645. Okay, now that I have my z-score, now I'm going to use the formula. And again, you could do either one of these. Let's pretend we used that one. We use the formula, we say x equals 98.6 plus 1.645 times 0.72, and we get that the x value is 99.78. And we've saved ourselves from having to look up the area in the table. Or we can do it entirely in the calculator, right? So like we can do it practically nothing in the calculator. We can do it a little in the calculator. But to be honest, if you're going to do it a little in the calculator, you might as well do it all in the calculator, where you do your inverse norm. And what you're going to give it is, so the area to the left is 0.95. Your mean is your 98.6 and your standard deviation is the 0.72, right? Which is what we did here. Oh, can't see that because of the reflection. So second var's inverse norm fully in the calculator means that we give it the actual mean and the actual standard deviation, right? So that's just something that I find that people get confused about, is like, wait, when do I have it the 0 and the 1 and when do I have it other things? If you're giving it a 0 and a 1 for your mean and your standard deviation, you're talking about z-scores. But if you have the mean and you have the standard deviation, if you plug that in, you're going to be given the corresponding data point, the corresponding x value, right? That is the x value that separates the bottom 95% from the top 5%. Okay? All right. Use the standard normal table or technology to find the z-score that corresponds to the cumulative area of 0.2247. Okay, if I have an area of 0.2247, that's less than 50%, so it's somewhere over here to the right. So this area is 0.2247. So if I'm given area, and I want to find a z-score, this is going to be my inverse norm. Keep forgetting I can't put this over. Oh, I guess I can put it over here with the reflection. inverse norm. So the area is 0.2247. That is the area to the left. I don't have a mean or a standard deviation, so I'm just using the 0 and the 1 because I'm trying to find a z-score, not an x value, and I get negative 0.76. If I were doing this by looking at the table, I would look in the body of the table, right? Because the numbers out on the sides are the z's. The numbers in the middle are the areas. So I have 0.2247. I would look up where is 0.2247 in the body and see where that corresponds to the z-scores. Use the standard normal table or technology to find the z-score that corresponds to the cumulative area 0.7507. All right, so this is more than 50%. So that means I'm going to be somewhere to the right. So here's 75 about percent shaded in. So again, if I'm given an area and I want to find a z-score, I'm going to use the inverse norm. So I'm going to go inverse norm, second vars, inverse norm, 0.7507. That's the area to the left. And I get, if I round to 2 decimal places, as it asks me to, I get 0.68. Okay. Use the standard normal table to find the z-score that corresponds to the given percentile. If the area is not in the table, use the entry closest to the area. If the area is halfway in between the 2 entries, use the z-score halfway between the corresponding z-scores. If convenient, use technology to find the z-score. Okay, so it's reminding you of all of those things that we've talked about before, right? We talked about how if it's directly in between, if these are the exact same distance away, you use the one in between. Or like, what was another one? Trying to see if there was one that I had circled over here. What's closest? Well, anyway, whichever one is closest, you use. If there are 2 numbers that are the exact same closeness, you use the value in between them. Okay, so the 90th percentile. So quick reminder, that is the 90th percentile. Okay. So the 90th percentile is the value that separates the bottom 90 from the top 10. Not that we have to do the math to say that that's 10, but that's just a reminder. So I'm going to go ahead and use technology because that's going to be faster for me than looking it up on the table. It might be faster for you to look it up on the table. I find that it takes me a while to find the numbers on the table when I'm looking for them. So for me personally, it's just faster to do over here. Second vars, inverse norm. The area to the left is 0.9, and I leave my mean and standard deviation as 0 and 1. And I get my 1.28. Find the indicated z-score shown in the graph to the right. So again, if I'm given an area and I'm asked to find a z-score or an x value, I'm using inverse norm, right? So we go second vars, inverse norm. The area is 0.1469. I don't have a mean or standard deviation. And even if I did, if I'm asked for a z-score, not an x value, I leave it as 0 and 1, right? For a z-score, you leave it as 0 and 1. Okay, this was the area to the left as opposed to the area to the right. And that's how I'm getting my negative z-score. Also, it makes sense that it's negative, right? Every time you get a z-score, make sure that it makes sense in terms of, is this supposed to be a positive number or a negative number? This is supposed to be a negative number because it's to the left of the mean. Okay. Find the indicated z-score. Again, same process. I have an area. I'm asked for a z-score. So I do inverse norm, second var's inverse norm. My area is 0.0951. Real quick, I'm going to just jump to this and say, don't forget that's the area to the right. And I want to make sure that my mean and my standard deviation are 0 and 1 because I've been asked for a z-score, not an x value. If I was asked for an x value, they would have need to have provided me with a mean and a standard deviation. But I was asked for a z-score, so I use 0 and 1. And that's how we get, again, if we round to 2 decimals, 1.31. And again, that makes sense because this is clearly to the right of the mean. Okay, last couple of problems here. And we're sort of switching gears a little bit, okay? So this is the last type of problem in this chapter. Okay, the lengths of lumber a machine cuts are normally distributed with a mean of 104 inches and a standard deviation of 0.3 inches. Mean 104, standard deviation 0.3. What's the probability that a randomly selected board cut by the machine has a length greater than 104.09? Okay, so if we were to kind of draw out what we're talking about here, I have a mean of 104. I like to write off to the side my standard deviation of 0.3. And they're asking me about the probability that it's greater than 104.09. So that's a little bit to the right. It's not very far to the right, but it's a little bit to the right. And so that's an x value of 104.09. And they want the probability that it has a length greater than that. So what's the probability that an x value is going to be in this region, in this shaded area? Okay. So I need to find that area because that is the probability that something is greater than that. Okay. So there's a few different ways to do that. So, oops. We want to find, sorry, we're going to go second vars. And remember when we were doing normal CDF, right? We have a lower bound, an upper bound, a mean, and a standard deviation, right? This is normal CDF because we are trying to find the area. Okay, now previously we were doing lower and upper bounds that were z-scores, but this time we have an x value. Now, yes, we could find the corresponding z-score and we could use that, but we don't need to. That's just extra steps. We're already given all of the information that we need in order to do this the fastest way possible. Okay, so the fastest way possible is that we do normal CDF. Okay, our lower bound is our x value of 104.09. Our upper bound is infinity, or 1 times 10 to the 99th. Our mean is 104. And our standard deviation is 0.3 or 0.3. Okay, so this is going to be the fastest way to find this. We don't have to do it this way. Like if they were asking for, maybe they want you to solve this like in pieces. Like maybe they say, hey, what's the corresponding z-score to a length of 104.09 inches, right? They might have you find that first, and then they might ask you for, what's the area to the right of that. But they didn't ask us for that intermediate step. They just want the final answer. So this is how we do it. Whoops. I think I put something in wrong here. Hold on. Let me go back and see what I plugged in wrong. Oh, because I didn't actually plug in my lower bounds. I must have just said it and not typed it in. 104 point, is it 09? Yeah, 09. Yeah, that makes a difference. Let's try that again. There we go. That's better. Quick side note, I typed in a super low number and then a super high number, right? As low as I can go and as high as I can go. That's why it gave me an area of 1. Because I pretty much asked it all the way to the left and all the way to the right as my bounds. And it's like, okay, well, that's everything. That's 1. So that's why I did that, because I typed in the wrong number. All right, so when we have 104.09 plugged in correctly, we get that this area, the probability is 0.3821 if we go to 4 decimals, like they asked us to. Okay, now, so here's where the other part of this chapter comes in, is part B. We know this information about the population, right? Right, we know we have a mean here, we know we have a standard deviation. This is population information, right? Population parameters. We have that, but then we're going to take just a sample of the population, a sample of 45 boards that are going to be randomly selected, and we want to know not the probability that any board in the whole population is greater than 104.09 mean, but that the probability that of the 45 we select, that their mean is going to be greater than 104.09, right? So you see how that's a slightly different question, okay? So in order to calculate that, we need to remember some of our formulas. So let me just go to our formula sheet here. Yeah, here we go. So when we're in 5.4, we're talking about sampling distributions. The standard error of the mean, which is the standard deviation of the sample means, is calculated by taking your population standard deviation and dividing it by the square root of the sample size. Okay. And we need that because that's what we plug in to find a corresponding z-score, right? We have the value minus the mean over the standard error, right? So it's not exactly the same formula that we had before of x minus the mean over the standard deviation, because we're talking about a sampling distribution. We're taking random samples from this population, and we're talking about the mean of those samples, right? Okay, so we have, I guess I'll put it down here, a z-score that is, again, I'll write it out, value minus the mean over the standard error, which is oops. So remember that we had a formula for that. It was the standard deviation over the square root of the sample size, right? So this is the formula that we're going to use to find the corresponding z-score here, right? Remember we talked about how we could, if we wanted to do that intermediate step, well, we have to do that intermediate step because we're being asked for a different thing. We're being asked specifically if we had a sample of 45 boards, not just all boards, but a sample of 45 boards. That's why we have to use this special formula, okay? So, okay, so let's plug all this in. So we have our value, which is the 104. It's not a bar. That's not a bar. Apologies, it's not a bar, not a bar. Did I write that in the bar? I did. It's not a bar. I'm gonna have to go back and fix that. That's fine. All right. 104.09. Oh no, it is a bar. I'm so sorry. I'm getting ahead of myself. I'm like, oh, it's the value, but it is that their mean length is greater than 104.09, right? We're asking about their mean length. That is a bar. Write that back on there. I'm not crazy. All right, 104.09. That is because we're looking at the probability that their mean lengths are greater than 104.09, that the mean of this sample of 45 boards, right? So that value is the mean of these 45 boards, the sample mean, right? The sample mean is the 104.09. The mean here is our population mean, which they can, because a quick side note here, I know I'm saying population mean, and you might be looking at that saying, well, that's a slightly different symbol than that. That's because the mean of the sample means is equal to the population mean, right? Because remember what we're doing here is that if you have random samples that are repeatedly taken, if you take the mean of those sample means, it's equal to the population mean. So the mean of the sample means is the same thing as the population mean, right? Okay. Over the standard error. So what was the formula for the standard error? It was that we take our, so the formula for the standard error of the mean is we take our standard deviation, which was 0.3, and we divide it by the square root of our sample size, which the sample size is 45. Okay. Now, when you go to plug this into the calculator, just be really careful, right? Like put that in parentheses, excuse me, or maybe do it in two separate chunks. I'm sorry, put that in parentheses. That's the more important one. When you're dealing with order of operations, you want to make sure this is what's most important to put in parentheses. Okay. So 104.09 minus 104 divided by 0.3 over the square root of 45. Also, you notice how I just hit the little right, oh no, you probably can't see that. I hit the right arrow to get out of being under the root so that I could close the parentheses. Okay, so I'm getting a z-score of 2.012. Okay, so that's a z-score. So now that I have a z-score, right, 2.012, now I can say, what's the area to the right of that? Right. And I can either do that in the calculator, or I can do that by looking it up in the table. I'm just going to do it in the calculator, right? So if I have a z-score and I'm looking for an area, that's going to be normal CDF. So I'm going to go second vars. I'm going to go normal CDF. My bounds, remember I'm using z-scores. So because I'm using z-scores, my mean and my standard deviation have to be 0 and 1, right? If I'm plugging in z-scores, which I have to do here because I have a different z-score for this than I do for if I wasn't taking a sample of 45. We're going to find that in just a minute here. But anyway, 2.012. Actually, I shouldn't write that there because that's not what that one is. All right, my lower bound, 2.012. My upper bound is positive infinity. So we're going to leave that as 1 times 10 to the 99th. I'm doing a z-score, so I need to have a 0 and a 1. Right? And that's how I'm going to get that the area is 0.0221. Okay. Normal CDF. My lower bound, 2.012. My upper bound, 1 times 10 to the 99th. Mean is 0. Standard deviation is 1. Even though, you might look at this and say, oh, but I have means and standard deviations. But we're giving it z-scores. If you're giving it z-scores, you got to give it the z and the 1. And that's how we get our area. Okay, so what they're trying to get you to see here is that for A, if we just say, well, what's the probability that a random board has a length greater than that? We have one, that's the probability. But if I have a sample of 45 boards and I'm saying, what's the probability that the mean of that sample is greater than that same value, I'm getting a different probability, right? Because those are two different things. So when you're doing the sample and you're talking about finding the probability of the mean of that sample being greater than something or less than something or between something, that's when you have to be using this formula, right? And you could even just block off this, right? So you have to find that corresponding z-score. Okay. All right. And then we have one more, very similar. The weights of ice cream cartons are normally distributed. The mean weight of 9 ounces and a standard deviation of 0.3 ounces. What's the probability that a randomly selected carton has a weight greater than 9.11 ounces? Again, that is an X value of 9.11 because that's ounces, not standard deviations to the right. They want the probability that it's greater than that. So the fastest way to find this is normal CDF. Lower bound is 9.11. Upper bound is 1 times 10 to the 99th. Because I'm giving it X values for my upper and my lower bound, I have to give it my actual mean and my actual standard deviation. Mean of 9, standard deviation of 0.3. Second vars, normal CDF. Lower bound is my X value. Upper bound is my X value. So because I gave it X values, I have to give it the actual mean and the actual standard deviation. Okay? If I wanted to do that the slightly longer way and find the corresponding z-score, X minus the mean over the standard deviation. 9.11 minus 0.3 over 9. Nope, I wrote that absolutely backwards. Sorry, I'm going really fast here because this is the last one. And you guys have been sitting through this for over 2 hours now. Sorry, our mean is 9. Our standard deviation is 0.3. That's better. Okay. 0.3, I'm going to go to, trying to think if I should go to 2 or 3 decimals here. I'm just going to go to 2 decimals here. Okay, so again, I can either do it that way and I just get my answer. But if I wanted to do it the slightly longer way, I would say, okay, well, my corresponding z-score is 0.37. At this point, I can either look it up in the back of the book, and I can say, if I look up a z-score of 0.37 in the table, it's going to give me the area to the left, and I would just do 1 minus that to get the area to the right. Or I can still use my calculator and do normal CDF, but this time I'm giving it z-scores as the boundaries. So that's going to be 0.37, infinity, or 1 times 10 to the 99th. And I have to give it a mean of 0 and a standard deviation of 1, right? If I'm giving it z-scores as boundaries, I have to give it 0 and 1. Also, that's a 3. I know it looks like a 5. So second vars, normal CDF, 0.37. No, not negative. 0.37. There we go. 0 and 1. Okay, now I am getting a slightly different number. 3556. Yeah, 35. So yeah, so if if I'm rounding to 2, I'm getting a slightly different answer. Okay, but it's close. This is going to be the fastest, most exact way. Okay, now to compare that with part B. Okay, now I'm taking a sample of 36 cartons. And rather than just looking at a single randomly selected carton and talking about its weight, we're looking at the mean of those 36 cartons and the probability that the mean of those cartons, those 36 ones, is greater than that same value, that 9.11. So similarly to here, where we had to first find a z-score, we have to first find a z-score. But this z-score is that super fun formula, right? Where we say the mean of the samples minus the population mean over the standard error of the mean, right? That's what we have here. The mean of the samples, the 36, minus the population mean over the standard error of the mean, which is the standard deviation divided by the square root of the sample size. Okay. So the mean of the samples, or the value that we're looking at, is the 9.11. The population mean is 9. The standard deviation was 0.3, and the sample size here was 36. So again, if you're plugging this into your calculator all at once, make sure that your parentheses on the top are there, right? Oops. Divided by. And then I'm going to hit the right, you can't see that, the right arrow to get out of being under the root so that I can close my parentheses. All right, so I have a z of 2.2. So the reason I wanted to do it this way is because I wanted you guys to see that the z-score of part A is 0.37, but the z-score of part B is very different. It's 2.2, and that's why we're getting such a different probability here, right? These z-scores are measuring two different things so that we're getting two different values for them. If we want the area to the right of a z-score, how do we do that? We do normal CDF, we do our lower bound, we do our upper bound, and because we have given it z-scores as bounds, we give it a 0 and a 1 for the mean and the standard deviation. Second vars, normal CDF, 2.2, 1 times 10 to the 99th, 0 and 1, and that's how we're getting that 0.0139, okay? So these last couple of problems, there were only 2 of them, but you can see how you do part A very differently than you do part B. So you do need to have this formula memorized so that you can do that. Okay. All right. So I'm obviously going to be emailing this review out. I will also send out a PDF of this. Again, this is just something that is an example of something that might be helpful for you to do as you're going through and looking at the material for the first time. It's always a good idea to take some kind of notes when you're learning. Also, don't forget you can come into any of the academic support centers to get help. You can use the online chat feature, and as I always say, your teacher is a great resource, right? If you've got questions, absolutely reach out to them. You know, if you're concerned about the types of problems that you're going to see on your test, reach out to them. They can give you some peace of mind with, you know, telling you, oh no, it's not going to be that difficult. It's only going to give you this type of question. Or yeah, I am going to be asking you questions that, you know, where you have to use the formula by hand or something. So definitely reach out to your instructors to get that kind of clarification. But otherwise, I hope this was helpful and good luck.